All right. Thanks, everyone. I'll be talking today about wallets, as my company works on wallets for 6 years now, Wallet Connect. My name is Pedro Gomes. I'm founder at Wallet Connect, and the title of this talk is about session authentication for smart accounts, which is quite a mouthful, like everything in Web3. And I think it's important that we start off by breaking down the lingo, because it's going to be a lot of words that are going to be spoken today about wallets. And pretty much the biggest difference that you see when you go to a Web3 application today is that we moved away from this login pattern to a connect pattern. But did we really change much about what is required about an application? Like, there's a lot of words like that are being thrown around whenever you talk about wallets, like the dApps, wallets, capabilities, sessions, permissions, keys, authentication, external accounts, smart accounts, signing, access. But at the end of the day, it all comes down to like the same concepts. And it's always very important that we kind of like revisit the first concepts that we have in like traditional like applications that we use every day. And authentication, I think it's a very important word that we have in mind, which has a definition of, in computing, of the process or action of verifying the identity of a user. And if you think from a user's perspective, they don't care about all of these words. They just want to get in. It's like, just let me in. Like, that's the whole point of login, of connect, authentication is just like, let me in. And if the user wants to get in quick, less clicks is more. Like, that's something that we always have to have in mind, not just for this talk, but also for whenever you design a good user experience, less clicks is more. So why is Web3 different? Like, why do we actually have to reinvent the wheel, change things around, and make things more complicated? Why can't we have like less clicks? I like to kind of always show this diagram because for me, kind of makes it easier to understand what's different about Web3. In the past, we had an application, or a client sometimes is called, that talks to a server. And there's like multiple components in a server, but obviously we want to focus on the authentication part. Because at the end of the day, what happened with Web3 is that we moved the authentication part into its own app, and we called it a wallet. And now what used to be a server is now a blockchain, and then you still have an app interface and a wallet interface, and then both of them talk to this blockchain, and we have like this really beautiful triangle. But did we actually make things more complicated unnecessarily? Like a wallet, when you think about, like, it's another application, but it consists of like these three main things. It has a set of credentials, it has some signing capabilities, and it tracks an account. And there's different types of wallets today, as some of you may know. Maybe you're going to learn something new today, which I hope so. And if you consider these three components, like the mobile wallets or the browser wallets that you have, they have a set of credentials that are usually a password or PIN code, and they run some local software that has some signing capabilities, and they target an external account. And so the hardware devices and cloud and MPC, they might have some differences around, like maybe they use biometrics or a PIN code or email or phone or social for credentials. And then maybe the signing happens either locally on a hardware or on a remote server. But at the end of the day, they always follow this pattern of like credentials, signing an account. But we never actually got to the part of authentication because realistically, we had to invent authentication all over again, because when you connect your wallet, you're just saying, I have this account, but it doesn't actually tell you if you do own this account. So sign-in with Ethereum was the first standard that kind of brought authentication to Web3, and it took so long after the Ethereum inception to actually have sign-in with Ethereum. And when you look at it, it's quite simple. It's like a message that says, this website wants to sign into your Ethereum account at this address, and I accept some terms of service, which is an optional pattern, actually. It's like you don't actually have to add that statement, but you can do. And when you look at it, it looks like a lot of like words, and what is this like? Is this really user-friendly? It's not, but it's still better than what we had before, which is some people would just like have a hash and say like, sign this, and consider yourself authenticated, and some websites still do in Web3, which is quite worrying. But when you look at it, like signing with Ethereum just recreated a very normal pattern with social login, where you will get access, for example, to a Google account, and there is some capabilities, and you either accept it or not. So signing with Ethereum already creates a really nice pattern here, where we have a very familiar interface in a text format, but some wallets today have already customized this interface to be more user-friendly, which makes signing with Ethereum a great success as a standard, in my opinion. One disadvantage of signing with Ethereum is that this only happens after you connect your wallet. So in a sense, you do create this session when you connect your wallet, but then you have to authenticate after. So we at the Wallet Connect team, we created a new standard, which is called CIP222, which is called Wallet Authenticate, very simply put. And what does it do? It's actually just, I like to say, like an upgraded version of signing with Ethereum. It basically takes you from the existing pattern where you connect and then you sign. But since signing with Ethereum is what we actually want to do, why don't we just like skip the whole pattern of connecting, and we embed the experience of actually establishing a session into just the signing. So we skip the connect, we just authenticate right away with sign with Ethereum, and you have a session. So you could say, like, is this enough? Like, have we succeeded into making a more familiar experience and making users happy just like they are with logging in with Facebook or Google or with their email and password? What about signing transactions? This is where things get really, really complicated, because I started with like the simple stuff, which is just authenticating yourself. But then at the end of the day, the whole purpose you actually want to connect your wallets to the blockchain is because you want to actually take some actions and sign transactions. So most people just close your eyes and approve, which is terrible. If you told people like 6 or 7 or 8 years ago that like that's what's going to be the normal pattern. So we actually have to do something better. And we still have to kind of think about how can we balance the convenience and security. Like the challenge with wallets is not creating a wallet. Wallet Connect today has more than 500 different wallet applications registered. Most of you probably use only 2 or 3 of these. Like if we actually did a survey right now, but there's 500 application developers out there building it. But balancing the convenience and security is really hard. It's almost like an art, because remember, less clicks is more. That's what we want to make sure that we achieve here, but it's not an easy task. So why is it not an easy task? Because wallets are based on this simple concept of public key cryptography, which made this whole idea of self-sovereignty and owning your assets possible. But this, yet again, it's more lingo. Let's try to break it down and understand what public key cryptography is. So you have a private key, you have a public key, and that's what makes us actually have a wallet. And with this public key, you can actually verify a signature. So you take a message, sign it with a private key, generate a signature, and it goes back to a public key, and you understand that this message was signed with this private key without exposing it. So that's how transactions go into the blockchain. Every transaction is a message that is signed with your private key that only you own. Therefore, only you have access to the assets and everything that you own on the blockchain. And so this happens in this manner, where you take a message, you sign with the private key, have a signature, it matches to the public key. And then we have this really interesting thing here that a lot of people confuse public keys with accounts, but it's not the same thing. We actually take an address from a public key by hashing it, and that's what actually looks on the blockchain. So you can then match a transaction or a message to that specific account. And this is what we call an externally owned account. If you saw in the previous pattern where I showed the mobile browser wallets and cloud wallets, we had all of these wallets are external accounts, but we want to do better. We want to make them smarter. Because externally owned accounts, as you saw, was taking a public key and just hashing it, and you get a single account from that. With smart contract accounts, which is actually quite a mouthful, I kind of get tired of explaining it and saying externally owned accounts and smart contract accounts. I think it's easier if we just like let's reduce it to just external account and smart account. Like there's only two types. So our goal here is like, let's make accounts smarter. Let's move from external accounts to smart accounts because at the end of the day, we want to sign transactions better. So a smart account is simply defined by a smart contract that is being deployed as your account. Instead of you having this public key that owns some assets, you deploy a smart contract and that becomes your account. But then you now have a problem because we just went into this idea that we're going to sign with Ethereum to authenticate yourself. So how can you actually validate if you don't have a key? No key, no signature. It's that simple. So if you have a smart contract as your account, how can you actually sign in? There's a standard for that. So ERC 1271 means signature validation method for contracts. So now a smart contract can actually be validating a signature and saying this signature matches the owner of this smart contract. And it's quite simple. Like, I don't want to be showing too much code, guys, because I don't think that's actually important. But I wanted to show you how simple this standard is. Like, maybe you will take like a while to actually read the whole thing, but it's just this. It's a single method that says, is valid signature. You pass the hash of the message, you pass the signature, and it returns what it's called like a magic value, which basically just says true or false. So if the magic value is returned, then it means it's a valid signature, and you can know that this signature is for the owner of the smart account. So what is an account? Like, we talked about external accounts and smart accounts, and just like we broke down wallets into three components, I want to also break down accounts into three components, which is signer, payer, and crypto. And unfortunately, when you talk in a cryptocurrency conference, you always have to say cryptography. I'm not referring to crypto as cryptocurrency, but actual, I don't know, like traditional cryptography. So an external account has a single signer, which is the public-private key that we talked about. That public key is the only signer for the external account. And the same thing happens for the payer, right? So when you send a transaction, you have to pay some fees or gas in Ethereum, and that signer is also the payer and will always be the payer, right? There's no way that the external account will have a different payer. And we have to use the same cryptography as the blockchain. So for Ethereum, we use CECP256K1. Therefore, the signer, which is the single signer, has to be the single payer and must use the same cryptography as the blockchain. With smart accounts, this gets even much better because in reality, we can't force every user to follow the same pattern. We need to give optionality. So by making accounts smarter, we can have multiple signers. Multiple signers could be multiple people, which is what we have the concept of multi-sig accounts. But multiple signers could also mean multiple devices, multiple applications. You can have a signer everywhere. And also, because you have multiple signers, you also have the ability to decouple this concept of signer is always the payer. You can have a signer and a payer completely separate. That could be you have a signer that owns the assets, or you could have the account owning the assets, but it's not the same as the one that signs, or you could have a third party subsidizing the transactions for you. And this is currently only possible with smart accounts. And the other thing the smart accounts also make it possible is that you can use any curve. Now you're not limited to the cryptography that Ethereum has decided to use, which is the same one as Bitcoin. You could actually use multiple cryptography curves, which makes it much easier for us to actually build better experience for users. So now, if you do have a smart account and you have like multiple signers and multiple wallets and multiple locations, like then this idea of like connecting becomes a little confusing because what are you connecting to? Actually, smart accounts makes this much easier because with external accounts, you ended up having like one account per wallet if you did not share the seed phrase around. And it's much better with a smart account because essentially you can have one smart account everywhere. Like, we reduce the complexity a lot because now you don't have to worry about having like accounts there, and then some assets are in another account. You can just have like one smart account. And because you have multiple signers, those signers can be distributed in multiple applications and wallets. But at the end of the day, in the blockchain, you have like a single smart account being tracked, which makes the experience much, much easier. So what it actually means to be connected, because we talked about how we authenticate ourselves, we connect, we sign some messages, but what is actually being involved in that process that actually makes the experience that Wallet Connect has built on top? The first thing that you do is actually exposing the accounts. So that's actually the account address that you see. And then the application is able to read some blockchain data. So for example, in the concept of defining if it's a smart account or an external account, we can maybe look not only just at the assets, but if there's some contract being deployed at that address. And then we can create a signer session, which we saw with signing with Ethereum. And then in the future, we can request a user approval for example, signing transactions and submitting transactions. So this is quite good as a concept because I want us to think about 4337, which is a very important standard for smart accounts, because the idea of a smart account actually delegating signature to multiple signers and having multiple payers becomes a really fragmented space. And we want to make sure that we keep Ethereum decentralized and the experience is still convenient for the users. So 4337 essentially creates a standard for all of these experiences to be built unified, and we all agree and to have the same pattern. Basically, if you think about the triangle that I had before, now maybe this triangle is a little bit more complicated now, because now it's not just an app and a wallet and a blockchain. Now you have a concept with 4337 of a paymaster. So the paymaster will be the one paying for those transactions. So the wallet needs to be connected to that. We have the signer. The signer may be in the wallet, may be external to the wallet, maybe even in the app, perhaps in the future. And then we have a bundler. And the bundler basically just takes a signature that the wallet will create that is signed by the user with the signer, and then the paymaster will pay for it. So there's a commitment from the paymaster. You did a user operation, because in 4337 we actually changed the name, because why not, make more lingo. So instead of calling it a transaction, you sign a user operation. And with this user operation, then you send to the paymaster commits, I'm going to pay for this, and then you send on the bundler. And the reason it's called bundler is because this is not supposed to use just for this wallet or this account. This is supposed to use by multiple wallets and accounts, and they just bundle everything together into one big transaction that includes multiple user operations, and it goes into the blockchain as a bundle. So this is quite a great pattern that, you know, it moves things forward. Maybe it doesn't feel like much progress, but if you were here like 3 years ago, this is like a breath of fresh air, because we've been talking about account abstraction and smart accounts for so long. But the problem now is, like, if you're a dApp, how do you actually discover if the wallet supports smart accounts? We always make an assumption that the wallet is an external account and it doesn't have all these properties of multiple signers and payers and different cryptography. How can you actually define that the wallet is a smart account without actually just, you know, checking if there's blockchain code? So there's a new standard called 5792, which is called Wallet Call API Methods, and introduces 4 different methods. But I think that it's important for us to take a quick look at here, because the first one says gate capabilities. And then there's a second one, which is send calls. The reason it's called send calls is because, as I told you, 4337 now includes the concept of user operations. So instead of calling operations or transactions, we just generalize it and call it calls. This way, we abstract from the dApp a different pattern between smart accounts and external accounts. We just send a call, and then it's up to the wallet to actually interpret this call, whether it's in a transaction format or in a user operation format. And then because we introduce a new pattern of calls as a generalized concept, we have a call status and a get call status and a show call status. But I think the most important thing that we should look at is the wallet get capabilities, because with wallet get capabilities, we actually get to learn about the wallet. So once you actually authenticate yourself, you can ask the wallet, hey, tell me about your wallet. What things can you do with this wallet? And this is only for illustrative purposes. This is not yet in production. This is just an example of, for example, you could have one address A and one address B, and one of them supports a paymaster service, and the other one supports like paymaster service and session keys. And this way we can actually have a little bit more information about the wallet and knowing, oh, look, this is a smart account and it has this paymaster service and maybe supports like some fancy feature like session keys, which we're going to talk about. And this basically answers a lot of questions, but does it answer the last question, which is what is the interface for the paymaster data, which is the data that the paymaster actually gives us in 437 that allows us to actually send it to the bundler, knowing that they will be the ones paying for our transaction. There's a standard also for that. There's been so much progress in the last 18 months around account abstraction, and I want to make sure that I show you all how we're actually going to have a much better user experience. The 7677 defines a paymaster web service capability. So building on top of the 5792, you can actually define this capability in a way that all paymasters will work in the same way. And therefore, apologize for more code, you end up having like these patterns where you can actually say, with these characteristics, you can actually send to a wallet, and then you actually know that they have always a paymaster. And this way, we have a more decentralized way for paymasters to actually work in the same way. But then, if we created user operations, are user operations all going to work the same way? This is still a tricky part because right now, maybe there's only a few implementations. So we have some libraries today that kind of abstract that and just say, if you use this account, then you use user operations like this. If you use this other account, you use operations like this. But then you're just going to have like a big list of different user operations. So instead, we also have a new standard called the User Operation Builder, which allows you to actually ask the smart account directly how to actually construct the user operation for this particular user. And it looks like something like this. This is a little bit more complex now, that we're getting a little bit into like which entry point does the smart account use, which nonce get call data, get the signature and everything, and we have like an execution target. But these are all steps forward for us to actually have more smart accounts and less vendor lock-in, such that like a wallet connects to a dApp and authenticates itself, and we can understand very easily without knowing ahead which account they use, how it will function. You construct the user operation, you get the paymaster data, and you can get started right away. So smart accounts, as I told you, allow you to have like multiple signers and multiple payers, and we already covered how user operations and paymasters are going to be standardized, but some functionality is going to be very specific to some smart accounts, and we need to make sure that, you know, we reduce the vendor lock-in and smart accounts are as interoperable as possible. So there's this concept of modules, which is a new standard, also 7579, which is minimal modular smart contracts, that tries to ensure that all smart accounts are built in a way that everyone can use the same modules. And this is really interesting because it creates a more competitive market for modules. One of the modules that we might start thinking about is when you lose all the signers, how can you recover your accounts? Like a module for recovery would be really helpful, but what if your recovery module works with smart account A but doesn't work with smart account B, so you switch wallets, then the recovery only works with that wallet? Then it gets a little tricky because did we really succeed into having interoperability if the recovery only works with that specific one? And it gets even more complicated with that because with user operations, we have some limitations that are not the same as transactions. So even something as simple as swapping tokens can get really locked into a specific smart account. So having a module for swapping tokens very efficiently and only working with a specific wallet is not great. So having, for example, I don't know, imagine Uniswap building the swap module and everyone uses the same swap module following the 7579 means that everyone can compete building the best smart account experience without having lock-in about specific modules. And then I think that if we continue in this mission of like making sure that we have as less approvals and clicks for the user, we want to perhaps like remove the wallet. I know that's quite controversial because that was the whole point, that we started like this self-sovereignty, that you have ownership over the private key. But I do believe that to some extent we will have, maybe 5 years from now, the same experience as we have with traditional Web 2. And I think that would be possible if we take all of the work that we saw before with 4337 and Paymasters and User Operation Builder, and we sign everything inside of a dApp. But that's a very big task. And currently, I think that that's the definition of a session key. Essentially, we created multiple signers for a smart account, but we always had this concept that these signers would be in different wallets. But if we put these signers inside of a dApp, they would be used specifically for a session. And session keys solve that, but how can we make sure that like we're not conflating security with convenience? Because maybe we're so caught up with like less clicks is more that we're sacrificing security. So there is a work around permissioning. The reason it says XXXX is because the standard is in progress. There's big discussions around this. It's a very controversial topic because everyone has very strong opinions about how to do this. But I hope that eventually we will have a standard around this. And this is, in my opinion, probably going to be the biggest unlocker for user experience, where you can actually give the dApp permissions to actually sign transactions for you. And that would be amazing because now you can actually have sign in with Ethereum and that's it. You sign in with Ethereum, you have some capabilities, you approve some permissions, and all of the transactions are signed with a dApp. Like one example of how this would work, you take a dApp, the dApp requests permissions from the wallet, you ask the user, do you approve these permissions? Similar to how we saw this in the Google login. Imagine having the permissions having a similar pattern inside of the sign-in with Ethereum, and then the user will say, I approve. Maybe these permissions would say stuff like, I only want this dApp to interact with this smart contract and cannot spend more than $1,000 or something like that. The risk factor will then depend on the user, will depend on the dApp. Maybe in some dApps you don't want it to be able to move any assets and it will only sign, I don't know, votes for a DAO, or maybe it can only submit posts for the lens protocols. Like defining the permissions has to be granular enough that the user feels comfortable giving that capability to the dApp. Once the user understands the permissions that are given to the dApp, then it can approve. This generates a permissions object that the wallet offers to the dApp, and then the dApp can have its own key for your smart account that will sign transactions. And then we skip the whole pattern of talking to the wallet, and now the dApp, because we have a user operation builder, we have a paymaster service, the dApp has all the information it needs to actually talk to the bundler directly. You no longer need to go to the wallet to talk to the paymaster, to the signer, because the dApp becomes a signer itself as a session key, and it knows how to actually fulfill the paymaster data to subsidize that transaction, and it just sends a call using 5792 with the permissions that we're giving in the permissions object, and then the bundler will validate all of that, say confirmed, and then you can just move on. So, can we secure session keys better? Because session keys, this is where things start getting a little like tricky, because if you do have session keys, then you're giving a lot of power to dApps. I think the way to do this is we've done a lot of ERCs, but we need to really change EVM. We need to upgrade EVM to actually support this. And some things are already in motion. So for example, EIP 3074 introduces the off and off-call opcodes to actually change how EVM works. And this means that the external accounts will now earn the capability of separating the signer from payer. So this thing that we actually talked before that was exclusive to smart accounts is now in progress to change in the EVM, which is really powerful, and it's now going to be included in the next hard fork. This is a big step for EVM because we had these three things for accounts, which were the signer, the payer, and the cryptography. And now we're actually going to change the actual payer capability to be the same for both external accounts and smart accounts. So that's really powerful because then we can actually have some session key functionality in the actual external accounts, which is really good. But I think we need to take a step further, and I would like to actually propose that all core devs to also include not just 3074, but the EIP 5003, which says insert code into external accounts with this new opcode of ZERP. So that means that now not only we move away from external accounts into smart accounts, but we actually give the ability for people today who have external accounts to upgrade their accounts into smart accounts, which is a big deal because a lot of these companies are building a lot of great smart account infrastructure, but they always tell you to deploy a new smart contract. And that's, you know, I have quite a lot of NFTs. That's a lot of NFTs going into a smart account and a lot of tokens and some positions. Maybe you have some loans on Aave, maybe some liquidity on Uniswap. Transferring all of that is going to cost you a lot. So if we have the ability to just upgrade your external account, which is an optional feature, this is not forcing everyone to do it, you would basically just send a transaction with this off usurp new opcode, and you'd convert your external account into a smart account, which is really amazing. So I think this is going to be a big step, but how do we prevent the session keys from actually being stolen? While we did create a lot of great ground with all of these standards, with User Operation Builder, Paymaster Services, 3074, 5003, at the end of the day, you still have this session key living in the app, which is still a little bit uncomfortable because the reason we created wallets was to actually put the keys outside of the app. So are we just always going to be in this like nervous mode? We need to have very granular permissions, or maybe something happens and someone steals the session key and starts doing things that are not supposed to do. How do we prevent them from being stolen? Passkeys. Passkeys are the best session keys. And passkeys are not the standard for Web3, actually. You might have heard about passkeys before. Like, there's this pattern already with like Google and Apple, where you can actually create a passkey instead of a password. And that means that the key management services that these companies offer can then be used to log in and authenticate into normal applications. This is supported in, for example, Dropbox or like Google, or there's like so many, honestly. At this point, I think there's a website that shows like more than 100 applications that support passkeys. So how can we actually have Ethereum also leverage this? And this would be the standard that actually makes it really possible. You will notice there's a small difference here, because Ethereum had a CECP 256K1 and passkeys use R1. It's a small difference, but it's big enough for us to actually have a different cryptography from the passkeys. So while smart accounts allow you to use different cryptography, it's very expensive to use different cryptography. And if the EVM itself supported passkeys, we could make every user operation cheaper by adding this precompile. So this would be the third upgrade that I would propose to the EVM to actually support passkeys, so we could fulfill the whole experience for smart accounts to just be more embedded into the dApp. So is this the end game for wallets? Did we complete our mission of having less clicks is more? I think to some extent, yes, because if you look at all of the things that we walked through this path, we started with the differences between Web3 and Web2, and we had an application talk to a server where the authentication lived. But now, in a sense, we recreated the same thing, but we flipped around, where the authentication does not live in the server side or in the blockchain in this case, but the wallet actually lives in the app. We have the ability to have smart accounts being upgraded from external accounts. We have user operations. We have passkeys securing your session keys. Session keys have very granular permissions. So nothing stops us from a single click with the wallet authenticate method to get the capabilities and generate an embedded wallet that you can very safely use for that application with very great security and convenience. So what is actually being connected now? Because we now kind of broke the triangle. You could almost ask, like, what does Wallet Connect have to do with this? Because there's no actual connection. You just do a sign-in with Ethereum, and everything just magically happens under the hood. Before, Wallet Connect kind of just bridged between dApps and wallets and vice versa. But now we actually have a much bigger world now. We have session keys, we have signers, bundlers, paymasters. In a sense, Wallet Connect's job just got even harder because now we have more parties to connect to. We don't only have to connect dApps to wallets, we have to connect to paymasters, bundlers, signers. We have to manage permissions for session keys. So there's a very interesting roadmap ahead of us for the Wallet Connect team to actually build the infrastructure for what I believe is redefining the wallet experience for Web3. This is something that, has been the mission for 6 years for Wallet Connect, and it's taken very small steps, and that's why it took 6 years, not 6 months. But now I think that we're really getting close with these session keys and smart accounts, and we really complete here our journey of having less clicks is more. I think this is the end game for wallets. I really hope so, because if we could just like use Web3 everywhere, then we would have succeeded. Thank you. Do we have time for a QA? I think you have to shout, or I'll take the mic there. Wait a second, the mic is coming. There you go, thank you.
So this is a problem that's been with Ethereum since basically its inception. And one of the big problems is the gas costs. Like doing anything on Ethereum costs gas, and gas costs money, and it costs more and more money. And so in addition to having less clicks, we also have this overriding concern of having less transactions. And now that the user will have to interact with a smart contract, and the smart contract will have to interact with other smart contracts. So do you still believe that Ethereum is for everyone, or is it only for rich people?
I mean, how do you define is Ethereum for everyone? Like for me, Ethereum is a network of EVMs. So the work that was discussed here is not exclusively for Ethereum mainnet. It would be for all the Ethereum rollups. So like, I think the gas conversation, it's a big topic for sure. Because for example, we had a big upgrade with 4844, which basically introduced the blobs and made the rollups cheaper, and therefore also made Ethereum mainnet cheaper because it created a separate gas market. But will the average user use Ethereum mainnet? My bet right now is no. And I don't think maybe that is even the success metric for Ethereum mainnet. Maybe the success metric is to have as many rollups as possible and still be viable for rollups to not go sovereign. Because that is a mission in itself, that all of these rollups are interconnected with each other, and Ethereum mainnet is the hub for all of these rollups. And I think that that's one of the reasons we've seen Ethereum mainnet not take so many steps towards user experience, because they were focused in lowering the costs and making sure that rollups are more viable. But fortunately, we have 3074 now, the first step towards like better user experience. But don't take it wrong. Like just because it's called the EIP doesn't mean that the rollups are not going to adopt it. In fact, I would say that rollups always seek to have as much equivalence to the Ethereum mainnet. So any steps that Ethereum mainnet takes towards better user experience, they get inherited by rollups. So we have a better user experience on Ethereum mainnet, that goes to the rollups. Rollups reduce the cost of gas, and essentially we can have the best of both worlds, where users use rollups, all the rollups use Ethereum mainnet, all have the consistent user experience across all the rollups and mainnet as well. So I hope that answers the question.
It does.
Thank you.
Thank you.
Thanks. Yeah, I wanted to ask, I'm trying to not be the party pooper here. EIP, or ERC, sorry, 5803, I think, or was it 5003?
Is it the wallet call it AP?
The
wallet call AP?
Auth ZERP.
Oh, the 5003, yes.
5003, right. How long can you do without it?
I mean, so this is a big topic. So just to reiterate the question, how long can we live without 5003 now that 3074 is going to get included into the hard fork? I always think that in this ecosystem, there's pessimists and optimists. I'm just so happy that 3074 is being included, but there's a whole school of thought that says that we cannot go forward with 3074 without making sure that external accounts have the option to upgrade themselves to smart accounts, because of the problems of multi-chain, where you can have 3074 on one chain and not on the other chain, and then if you don't have 5003, you can't guarantee that you upgrade yourself in every smart account. Personally, I'm on the optimistic side. I'm just happy that we have 3074. If we do not get included into this hard fork, I don't think it's the end of the world. But if you do have some spare time to include both EIPs in this hard fork, that would be great. I don't think we're going to disappear as an ecosystem because we include 3074 without 5003. I know that if you go to the discussions on Twitter, some people are of the opinion that we can't do one without the other. I believe it's possible to do one without the other. Especially because 3074 is not just for external accounts. It's also allowing the whole ecosystem with 4337 to be leveraged by external accounts. There's so much infrastructure being built today with 4337 that external accounts can't use, and 3074 allows them to leverage that. But of course, like they would be more beneficial if they had 5003. So I'm gonna still push for 5003. If we do get it, we do. If we don't, it's not the end of the world.
Right, I'll give useful one more question if anybody has one. No?
Hello, thank you for your attention. And how we can trust provider like wallet connection if wallet connection has objection to censorship? For example, situation in the Russia and Ukraine, wallet connect disconnected all people from the Russia, from Russia IP, I think.
Sorry, can you speak louder? I heard something about censorship resistant and Russia.
Yeah, for example, wallet connect it's a centralized provider, yes, and wallet connection have censorship. For example, wallet connect blocked all people from the Russian IP. How we can trust wallet connections? And same provider, for example, if we use more deeper connection between wallets, for example, if we have Badler connections, have trust and my payer connection via wallet connect, for example, in these situations, user from the Russia can get this data, these providers and tokens.
To simplify for the audience, like how can people still use Wallet Connect that currently, today, April 2024, is a centralized provider if they're gonna block in certain countries? Maybe there's some misconception because back in the day, we did block for 24 hours Russia by mistake. And we did apologize for that. That was an unhappy incident, but it's not blocked today. But Wallet Connect is evolving into a network of providers. We did have a big mission to actually upgrade Wallet Connect V1 to V2, and that made us move into a single provider architecture. But we're currently onboarding third-party providers to service Wallet Connect. So Wallet Connect will be available as a network of providers, not just the current single provider. And we are actually going to have multiple node operators in the network. And just to reiterate, we do not block Russia today. That was 24 hours. Bad 24 hours, but it's been solved. And it will be furtherly solved when we have more node operators serving different audiences. So Wallet Connect network will be strong and stable.
Thank you.
Awesome. Thanks, everyone.